Hi everyone, this is Mr. Bozade, and today we're going to be talking about Unit 4, Target 1, which is finding work and power using equations or graphs and understanding how that relates to energy. In this video, we are specifically going to focus on power and how we use the power equation. So, a good place to start is to write out the power equation. And the power equation says the change in energy over the change in time. What does it mean to have a change in energy over some change in time? Well, that really means that we're thinking about how energy is either transferring into a system or out of a system, or how energy is transforming within a system. One of the things that is kind of a misconception about power is we think about, like the big football player is super powerful. But actually, what this equation is telling us is that power is a rate. It's really the rate that energy is being transferred or transformed. So you don't necessarily have to be super strong to be powerful. You just need to be able to transfer or transform energy quickly, and then you're powerful. And we're going to see this play out in the example that I've listed below. Who in this example is more powerful? A football player who can bench press 300 pounds or 136 kilograms, or is a child more powerful, a child who can lift up their 3-kilogram doll? Well, like I said, your intuition might say, hey, check out that football player. That football player is lifting 136 kilograms, and this little child is just lifting 3 kilograms. So that football player is more powerful. But in actuality, we don't know, because they're both transferring or transforming energy as they lift their objects. But the question is, at what rate are they transferring or transforming that energy? And in fact, we're not even given enough information at this point in the problem to make an educated guess about that. So let's add a little more information. Let's say that they both lift their objects upwards 5 meters, but because the football player is lifting this very heavy mass, or this very heavy weight, it takes him 10 seconds to lift it up, that 0.5 meters. But the child is lifting this much lighter doll, so the child lifts it very quickly in 0.1 seconds. All of a sudden, this question, who is more powerful, becomes a much more complicated and interesting and complex question. Because while the football player is clearly transferring or transforming more energy, delta E over delta T, the football player is transferring or transforming more energy, he's doing it over a greater time. On the other hand, the child is transferring or transforming less energy, but he's doing it, or she is doing it, over a smaller time. So it's going to be interesting to see what the results are, and let's give that a shot. Let's actually calculate this out and see what the answer is. All right, so we'll do that in the context of our LOL diagrams, because that really helps us visualize what energy is being transferred or transformed. And to simplify this problem, I am going to make our systems include everything, all the objects that the energy are being transferred or transformed within. And that way we're going to have no work done in this case. So for example, what's happening is that the football player's transforming his chemical energy into UG for the barbell, gravitational potential energy of the barbell. So this is the transformation that's taking place when the football player lifts up that barbell. Similarly, because I put the child in the system over here, the child is transforming his or her energy into gravitational potential energy as the child lifts that light 3-kilogram toy. All right. So, like we just discussed, in both cases, the change in energy is the transformation of chemical energy into UG. The change in energy is the transformation of chemical energy into UG. So let's throw in some values and answer this question. The first thing we need to know is we need to find out how much energy transformed into UG. And we just apply our gravitational potential energy equation, mass times gravity times the change in height. And for the barbell, we find that that is 666.4 joules. So when that football player lifted the barbell, he transformed 666.4 joules of energy from his chemical energy into gravitational potential energy for the barbell. For the child, it's going to be a far less amount of chemical energy that is transforming. For the child, only 14.7 joules of energy is transforming from that child's chemical energy into the gravitational potential energy of the doll that the child is lifting. And if the question were asking how much energy, who transformed more energy, then it would be a no-brainer. It would be no contest. That football player transformed way more of his chemical energy, or used up way more of his chemical energy in lifting the barbell than the child did in lifting the toy. But that's not the question. The question is asking who is more powerful, and we need to figure out who's doing that, who's transforming energy at a faster rate. So we need to take these values for energy that was transformed and divide them by the time it took to find the actual power or the rate. And so we find that for the football player is transforming that energy over 10 seconds, which is 66.64 joules each second, or joules per second. Now we have a special unit for that, joules per second, in case you forgot, and that special unit is watts. So the power for the football player in lifting the barbell is 66.64 watts, or 66.64 joules per second. The child, on the other hand, transforms the 14.7 joules of energy in 0.1 seconds, which is 147 joules per second. So each second, that child would be transforming 147 joules, whereas the football player each second would be transforming 66.4 joules each second. And surprise, as you may have guessed, I set this problem up so that we actually discover that the child is more powerful than the football player. And while on kind of the surface that seems like a surprise, because we traditionally think of power as being strong and big, we need to keep in mind in physics, power is actually the rate that energy is being transferred or transformed. And because the child is transforming their energy in less time than the football player, the child is transforming energy at a quicker rate. And there you go. Pretty cool. All right, I hope this was helpful. See you later.